Hello, everybody. It's Thursday, which means it's another episode of Simon's Things on Thursdays, the show where we look at using hardware IoT stuff with Redis and sort of maybe some lower level concepts than you'd see in some of our other live streaming output here on the channel. So first off, apologies, I'm a little bit late today. We're running about 2 hours behind the normal schedule because it's sort of the end of our quarter here at Redis, the company, and we were doing some planning and I got called into some meetings. So those done, we now return to literally normal programming just a little bit later. So this is the second part of a two-part project. I like to sort of have project-based streams. So we try and build something that shows a Redis concept, and sometimes that takes, I think 5 is probably the longest number of weeks we've taken over a single project. But I kind of think like 2 to 3 is a good size. So this is part 2. So for those of you who are joining and are new to this and haven't seen part 1 yet, then go find it on YouTube/Redising, which is our YouTube channel. I have a playlist there, so you can find it under that, or just go search for things on Thursdays. And what we were doing was we were looking at Redis Streams, which is a way of doing a couple of things with Redis. It can be like an append-only log, or it can be a buffer between distinct processes that run at different speeds. And we were looking at something that I've sort of revisited a few times in different ways in these streams. So we've done it in Node-RED, we've done it in Python and JavaScript. And what we generally have is an example whereby, imagine we're a hotel and we have what's called a stream producer or a series of stream producers. And those are people or events that are generated maybe by smart TVs in rooms or something that record guests wanting some sort of room service or some sort of interaction with the staff. So they might want like more towels, or they might want room service. They might want a couple of burgers delivered, or they might want a taxi, or we might have a phone call for them. So we have producers that generate these jobs, and there can be many of those. And they put them all into a Redis stream, and Redis timestamps that for us and keeps it nicely organized. And then what we saw in the last week, this is where it gets difficult. I'm talking about Redis streams and last week's live stream. So last week's live stream, we looked at different ways of consuming that stream. So we could have a single process. So like imagine, a single staff member that has to do all of these jobs, and they pull them off in sequence and say, yeah, I've done that one, I've done that one. And they keep track of where they are in the sequence. Then we looked at, well, that's not a very good customer experience. How do we scale that? And we had multiple instances of those consumers, but they need to work collaboratively. And we looked at a method that's built into Redis called consumer groups. And that allows us to basically say all of these instances of a process are acting as like a single multi-headed consumer. And between them, they're going to process everything that's in the backlog. So every person working won't see every job, but between them, the 3, 4, 5, how many people we've got doing the job will clear the backlog collaboratively. And when we do that, Redis tracks that information for us. So who's got what, who gets next, and everyone gets like their own individual view of the jobs. And one of the things that you can look at, or you might be interested to find out about when you're working in this model, so say you've got like microservices or something, you want to know how far behind your consumers are. So if the rate of production is higher than the rate of consumption, you might have like throughput SLAs. So we might say we want to respond to all customer requests within like 90 seconds or something. So you're going to need to scale up your consumers. You're going to need to add more. And when they've caught up, you can kind of like scale down a bit. This whole theory of like when you should do and don't do that, so that you don't end up in like a flapping situation where it's like, oh, it's busy, it's quiet, it's busy, it's quiet, and you sort of constantly tear things down and then stand them up again. Redis 7 added a bit of information that allows us to say how far behind the consumer group is on the stream of events. So we looked at how we could do that. and we ran some events into a database, and then we were going to use one of these little Raspberry Pi Picos, and we were going to use some LED lights, and we were going to basically show that information as a sort of physical status, and that's what I'm hoping to achieve today. So let's set the scene a little bit. We've got Faithful Camera 2 here is looking at another Raspberry Pi Pico W. That's just running some test code that we'll look at later, and it's turning each of those LEDs on. They're actually diffused with a bit of black electrical tape, because if you take that off, they're too bright for the camera. It's possibly a little bit too much diffusion for the light situation that we've got today, but basically there's a blue LED at the bottom of that stack, and there's like 4 green ones and some red ones on top of that. Sorry, some orange ones and then some red ones. The orange ones kind of look a little bit brown through there. But we're going to use this as a sort of traffic light system for how far behind in the queue are we, or in the stream are we with processing things. And yeah, hopefully today we'll be able to write some MicroPython that connects that thing to Redis, and look at how we're operating the lights, and look at how we wired it up. But first, what I wanted to do was actually run some data into the system so we can see how that's going to work. So last week we started out with a blank database, and that's where we're going to start again, just because it's relatively quick to create some data. So I'm going to share my desktop here, and we have this code base here, which is essentially going to be our sort of server-side stuff. It's going to be the producer, so the front desk that adds things to the stream. And it's going to be a consumer group, so workers that take things out of there. And I'll just post that into the chat as well. So if anyone's interested in that, you can grab that and take your own time over looking at it. It's pretty easy to set up. If you wanted to play with this yourself, there's an option to run the thing entirely in Git pod, and it will get everything for you and run it all in Docker and cloud, or you can set it up locally. So I'm going to go with local, as we did last week. So I've got 2 things in here. I've got a producer and a consumer group. My producer happens to be written in Python. As we said last week, it could be written in anything. And just a quick run through, this is literally all of the code. It would probably help if all of the code was a little bit bigger. So we are just basically saying we want to have a stream key called jobs. We've got a list here of different types of job that we might want to do. We've got a Redis connection, and then I'm just going to go into a while true loop. So forever, I'm going to create a random job dictionary, and that job's going to contain a room number that's randomly generated. And it's going to be a random choice of one of these job types. I do like how Python has these sort of higher level, I want to randomly pick something, random.choice from a list, and it just does that. And from there, what we're going to do is use the Redis xadd command that puts it into a stream. We're going to put it into the stream whose key is named jobs. And what we're going to store in there is this dictionary, so these name value pairs. And Redis is going to timestamp that for us so we can keep track of when it happened and keep it in order. And then we're just going to print that out, and then we're going to go to sleep for a random amount of time and then do the whole thing again. So the producer or the front desk is going to create these jobs. It's just going to do it forever. I've got a completely blank database here with Redis Insight, so nothing up my sleeve, no keys in the database. So how do we go about sort of bootstrapping this? Well, one of the fun things with Redis is I don't need to create the stream. Adding to a stream that doesn't exist will create it for me. So there's no create step here. So I can go ahead and run this code. Let's do that now. So if we go in the producer folder, I'm using a virtual environment for Python to keep my dependencies sort of tidy as I work with lots of Python projects. And then I should be able to do Python producer.py. And off it goes creating jobs. So 102 wants extra pillows. And then over here, if I refresh this, you'll see I have a stream key called jobs now. And if I click on this, let's make this a bit bigger so we can, there we go. you can see that in here, I have the data that's piling up, and I can turn on auto refresh in Insight, and we can literally watch it create new jobs. So there it goes. It's making jobs. And we could leave that running. I'm going to stop it for a moment there. And I'll leave that terminal as the producer terminal because we're going to come back to that. Now we're going to want another one. And let's have a look at the how the staff are going to work. So the first thing that you notice in here is my consumer group for staff. This is written in JavaScript. It's Node project. Again, this is a totally arbitrary choice. I could have written this in Go or Python or anything that's got a Redis client. These two processes, so the producer over here and the consumer group over here, they're just talking to each other through Redis. They don't need to know anything else about how they're implemented. So I should probably show some code for the consumer group. So here we have the consumer group code. And what it's going to do is basically, it's when it starts up, it wants a consumer name. So we give it like the name of the staff member to identify itself as a distinct process in this consumer group. So it could be like Simon or Josephine or Justin or Savannah or anybody we like. And what we're going to do is we're going to act as part of a consumer group called staff. So every instance of this code that runs is going to process the stream as if it was a single instance named staff. And however many things are in staff are going to collectively process it, and Redis will share out the work between them. So we're going to connect to Redis, and we do actually have to create a consumer group for the first time here. So we're just saying, let's create a consumer group called staff. And we have to tell Redis where we want it to start consuming in that stream of events. So I'm saying 0, which is the start. So start with the first job in the stream. Seems a fair assumption. And if this thing here throws an exception, then the consumer group already exists. So we'll just not worry about that. And once we've got our connection running, what we're going to do is, again, we're going to go into a while true loop, which is going to loop forever. And we're going to use this xread group command that we covered last week. And we're basically going to say, hey, I am reading on behalf of the staff consumer group, and my name is whatever we fed into the process arguments. And so I'm staff Simon, I'm staff Josephine, staff whomever. And then we're going to say, I want to read from the job stream. And normally we will pass in like the ID of a message that we've already seen, and it will give us the next ID back after that. Because Redis is managing who sees what in this consumer group case, we just use this special ID is greater than. And that basically says, give me a message that no one else in my consumer group has seen yet. And then we're going to say to Redis, I only want one message. And if there aren't any messages that satisfy this criteria, so we've got to the end of the stream, then hang out block for 5,000 milliseconds, 5 seconds, and see what happens. And then if we get something back, we'll just log it and sort of unpack the job ID and job details from that, print out the details, pretend to do the job by falling asleep for a random amount of seconds. And then we're going to tell Redis using this exact command that is kind of unique to the consumer group scenario that, yeah, we did the job. You know, we didn't like have an accident on the way to doing the job, or we didn't spill the coffee on the way to delivering it. And the job doesn't need doing by anybody else. It's been done. There are mechanisms in streams for detecting jobs where a consumer has read them and not explicitly acknowledged them yet, or for a while, and then taking action. Like we could assign them to another consumer, or we could put them on like a rework stream or something. And that's something that I keep promising to look at in a future stream, the sort of like non-happy path of what if the consumer that's doing the job has a problem with it. Or another scenario that can happen in these streaming solutions is what's called a poison pill message. So the data that arrives into the consumer is corrupt or missing something or not as expected, and it crashes the consumer. So every time anyone goes to read it, it crashes it, and we have to like remove that message from the stream. And there's ways of identifying that that is going on. And we're going to look at a little bit of that with the streaming lag, which is how far behind these consumers are behind a producer. So first off, what I need to do is go and run one of these. So we'll run it and we'll give it a consumer name. So back to the terminal here. My producer's not running at the moment. I have got 5 entries in the stream. We don't have any consumer groups yet because we didn't create any. So what I'm going to do is do node consumer group.js Simon and make myself the first and only consumer. And let's do let it run. It's picked off the first message and done that. Okay, it's picked off the second message and now we'll stop for a minute. So what happened here is I've read a couple of messages from the stream and I've acknowledged this one and said, yeah, I did that. And then while I was doing this one, I've something's happened. The process has gone away. So we didn't acknowledge that. So what we can do with Insight here is let's look at the state of this. So now we have this consumer group called staff. So far, there's been one instance of a consumer that identifies as staff. So that's Simon. We've got one pending message, which means that consumer said, yeah, I've read a message that it hasn't acknowledged yet. The other one that I did read and then acknowledge won't count for that number because I acknowledged it. And we can dive into this consumer group here and you can see the list of the consumers. And this is the time since Redis last heard from this consumer. So I've been idle for this long, or my consumer process has died and not been restarted. And then what we can do with Redis 7 is we can start to ask it questions. So let's clear the workbench here and do xinfo. I think it's groups, and then the stream name. So we can say to it, okay, tell me what you know about the consumer groups. And that's partly what Insight is using up here to power this view. So what it's telling us is that for each consumer group, we'll get all of this information. We only have one consumer group at the minute. So that group is staff. There's one consumer in it, one pending. The last thing that was delivered to a consumer was at this time point. We've read 2, and then this is what we're interested in. And both of these entries here were new in Redis 7. So before, you used to have to kind of calculate this for yourself, and now Redis is doing it for you. So we could say, oh, we're 3 messages behind. And, we might have a threshold where we say, oh, if it gets to more than so many messages behind, then add another consumer, see what happens in a few minutes, add another consumer if necessary, or stand one down, depending on how this number's trending. So we can pull this with the xinfo groups command, and we just pass it the name of the stream key that we want. So quick demo of multiple consumer. So I've got one window here, and I'm going to have a second window for another instance of the consumer. And let's do node consumer group.js, and we'll call this one Josephine, who is a member of our video team. And we will do node consumer group here, and we'll call this one Simon. Start Simon, start Josephine. And now what's going to happen is Simon and Josephine will collectively clear this backlog because nothing's adding new jobs at the moment. And they'll do it between them, and we'll hit a situation where both of them realize there's nothing to do because Redis isn't giving them anything new on top of what they've seen already. And if I go back here now and refresh this, you'll see that Josephine and Simon are members of the group. Simon's still got this one pending because I never did go back and fix that message where I stopped the consumer. So it thinks that there's still one that isn't maybe fully acknowledged or fully completed, and we might want to look into that if we were looking at non-happy path scenarios. And then if we go back to the CLI here and we just hit up and run this command again, what you'll see is now we have 5 entries read. There's 2 consumers that have been part of this group, and the lag is 0. So we're all caught up, which is consistent with what we're seeing here. So if I now restart my producer and add, it'll start adding some more jobs. You'll see Josephine picked up that cleaning job, first one that got added. And let's see what happens now. So extra towels, Josephine got that one as well. Eventually, it might start to get ahead of itself. Oh, there goes another extra towels job to a different room, and I've been given that one. And you can see more easily how these consumers are sharing the work between them, so how we scaled that. And if we go in here and run our xinfo command again, you'll see we're pretty much running level with the producer. So we aren't falling behind. However, two can play this game. So we can have multiple consumers processing things, but we can also have, just activate my environment. We could also have multiple people working the front desk or people putting things on TVs. So now we've got like twice the amount of jobs coming in as this one starts to add things. And let's see how we're doing now. So we're still doing okay. So we're pretty well balanced at the minute. But you can imagine a situation whereby if Simon goes for a break now, for example, and poor old Josephine's left doing all the work, you may eventually see that we start to build up a bit of a lag. There we go, lag of 1, lag of 2, lag of 1. So as there are now two things creating jobs and only Josephine, who is over here somewhere, actually doing the jobs, you will see that this lag has built up. So we got a lag of 3 out of, we've done 26 things. If we want to see how many things have ever been created, we just do excellent job. So 26 out of 32. And it's currently 4 behind the current endpoint of the stream. And the other thing that I'll just go back to, and I always say with streams until I'm sort of blue in the face, is all of this consuming from the stream does not change the state of the stream. So we are not like, it's not like a queue that you build with a Redis list where we're popping things off and they're removed from the stream. We would need to use a command called xtrim to basically say, hey, I'm finished with all the entries up to this particular time point, and it will clear those out of memory and clear them out of the stream. The reason why consuming doesn't clear them out of the stream is because this is designed for a sort of microsystems architecture. We don't know how many processes need to read from this or where they're at with it. So at some point when all the processes have said, yeah, we're done with this up to this certain time point, you can come along and chop the stream away. You can also trim the stream whilst adding to it. So if you wanted to create a capped stream of like, make this just the last 100 jobs for some reason, or just today's jobs, then you can do that. So that's kind of how you manage those. So I'm going to stop everything here. So that stopped the producer, that stops Simon, and let's make sure we've stopped Josephine as well. And I want to stop it in a situation where we do have some sort of lag going on. So we're currently like 11 behind. Maybe I'll run that down a little bit by running the Simon consumer and like burn off 4 or 5 jobs here. And there's a reason why I want that number to be less than 11 that we'll look at in a moment. So that can do that. And while it's doing that, quick reminder that we do have a Redis University course for streams. It's our RU202 course. If you go to university.redis.com, you can sign up for that for free, and it's entirely online like all of our courses are. So, okay, we've burned off some jobs by doing them. So hopefully we've got a smaller. Aha, I think I've got another producer still running. Yeah, look at that. So let's burn off some more jobs by running the consumer for a moment and get it under 10 this time without also running the producer at the same time. Because that's how we're going to win with a single consumer. Yeah, we could have run lots of consumers and so on, but nearly there. We'll get it down to, I don't know, 5 or 6 sounds like a good number to me. So let's keep waiting for that. 8. And basically what we're going to do is, imagine this was your workplace. You might want, that'll do nicely. You might want some sort of way of making this number pretty visible to people in your workplace so that a planner could see what to do. Or if this was like, microservices and you were running everything in like a cloud environment, you could possibly automatically monitor this. And when the number hits a certain amount, you could use that to trigger automatic startup of more consumer processes, for example, and then automatic scale down as needed. We're going to go the sort of visibility route because this is supposed to be an IoT stream. So we are supposed to use some hardware. And essentially, we're going to sort of make a bit of a meal of building an indicator for this, but it's just kind of a fun thing to do. So what are we going to use to do this? Well, we've got, let's bring the Raspberry Pi view back in here. So we've got a Raspberry Pi Pico W device here. It's slightly off camera at the minute. So here's one. And what this is it's a very small microcontroller. It's like about the size of a stick of chewing gum. It has these headers connected to it. Mostly they come without these, and it requires like 40 solder points to get those on. But Raspberry Pi do sell them with these pre-done, so you don't need to have a soldering iron to be successful with one of these. And if you can't find the Raspberry Pi factory version of that in the supply chain at the minute, which is difficult, go check out Pimeroni. They have decided to use some of their own equipment to solder these on for you, and they do this headed version. So that's a bag that these come in. They generally have good stock of those, and you can buy them. And they come, this is actually one of theirs. So it's exactly the same device with the headers in, which allows us to attach it to the breadboard or plug wires into it and use these GPIO pins, which is how we're going to control the LEDs. So what we've got on the right is kind of a complicated, well, it's a simple wiring arrangement, but there's just quite a lot of it. So we've got 10 LEDs over there in this tiny little bank of LEDs. That's a product that I showed last week. I got this one off of eBay, but you can get them from other places, and they're pretty cheap. They're like about £1 or they're around. And then each of these wires that you see to the left of the LEDs, each one of those connects to a GPIO, so a general purpose input output data pin on the Raspberry Pi. And we'll look at what that means. And then to the right, you can see a load of things that are sort of brown with rings on them. Those are resistors. They're sort of taking the current down that's provided by those wires on the left, which can either be no volts or about 3.3 volts. That's taking the current down a little bit so that number one, we don't blow up the LEDs. And number two, they're not like super, super dreadfully bright. And they're still so bright that I've had to put some tape over them so we can even see them. And then towards the back there, there's a single black connection, and that is the ground connection. So that completes the circuit back to ground on the Pi Pico. And every one of those resistors to the right of the LEDs, that's connected up to the ground. So we've got positive or nothing coming in on the left to each one, going through the resistor, ground, back to the, and there's your circuit. So we've done that. And I kind of did that off stream because it's not very entertaining, and you need to make sure you make a good connection with each of these. So I did write some test code that's just moving up and down the LEDs like that, and we'll see how that works. So I'll put this back. I will bring the desktop back, and let's go and take a look at what the Pi Pico looks like. So this is a really nice graphic that Raspberry Pi provide of how to hook things up to the Pi Pico. So this looks quite overwhelming if you're not familiar with what's going on here. Basically, these devices have 40 pins. So each of these gold things in the corner here, they have numbers. So there's 1, 2, 3, all the way to 38, 39, 40 on the other side. And they can perform different functions depending on which position it is. The functions are listed out here. So some of the things that we need for this circuit are we need a ground pin. So these black GND ones, so ground, as you see over there. So any of the black GND ones, we connect that black connector to. I mean, the color of the connector doesn't matter. It's just a good visual aid for that. That's my ground. And that goes through each of the resistors into one side of the LEDs. And then what we need is a controllable source of power. So anything that's green here that sort of says GPIO, we can use in code to say, hey, Pi Pico, set that to have 0 volts going out of it, or set it to have 3.3 volts. And we've got 10 LEDs and we're operating them independently of each other. So the sort of lazy way of making that circuit is let's just use 10 of these. So we've got GPIO 0 through to GPIO 9 down the left side there. And those are the ones I've used. There's a couple of breaks for ground ones in here. So like GPIO 2 is actually pin number 4 and so on. But basically all we need to know is these GPIO numbers, and we need to wire it correctly. So let's bring it back up a little bit. So each one of these goes to the corresponding pin. And if I pick the camera up and try and move it, maybe you can see there's it's quite busy down the left where those 0 to 9 pins are. And then down the right, we've just got the ground. Let's put it back and hope that it stays in focus, because the other thing with LEDs is they love messing with the focus on your camera. So you can set this up and think, oh, great, it's all in focus. And then the light changes or something happens and all of a sudden we can't see. So yeah, we've created that circuit. So if you can imagine the first 10 of these green ones are each connected to an LED. So 0 is connected to the blue one, which is like the lowest level of backlog that we're going to use. And then there's some green ones and they're connected to, I'm using a cheat sheet. So they're connected to pins 1, 2, and 3, and then, 1, 2, 3, and 4. We got 4 green ones apparently, and then we've got 3 orange ones for things might be getting a little bit bad now. Pins 5, 6, and 7, and then 8 and 9 are red for whoa, we're really getting behind here. We need to do something about this. So in order to get this information into the Pi Pico, we need to do a couple of things. So we need to connect it to a wireless network, and then we need to use some sort of Redis client or the Redis protocol to go over to Redis and say, hey, Redis, run that xinfo group command, and it'll send us the data back. And we need to pass that out on the Pi Pico. We also need to control the LEDs. So I have 2 code bases for that. So I built what you currently see running down there, which is something that just runs up the LEDs and down again. And I'm going to just click there, and we don't need tree main. I'm going to share this in the chat. But if you want just a start point for how to work with this particular set of LEDs, but you could adapt it to other stuff. So I'll put that there. There it is. So that'll be in the chat for those that are following along later. You can see what we've done here. So this is MicroPython, which is one of the coding options for the Pico W. I like it because it's quite approachable for a lot of people, and also it's interactive. We can get a REPL, read, evaluate, print loop. I think that's what it stands for, on the Pico, and we can mess with that from VS Code, and it's just really handy for basically messing around with stuff and see what happens. So I've got some code here that let's make that a little bit bigger, and we'll look at how this is going to work. So the code that you see running down below at the moment, what that does is we've created a list here of pin objects. So MicroPython is Python, but adapted for these microcontrollers. And a common thing with these microcontrollers is they have these GPIO pins. So you see here, I'm using a standard library that's built into MicroPython. So I'm saying from machine, import pin, and that represents a single pin that can be used for different things. And here we're saying I want each of the first 10 pins, so 0 through 9. So GPIOs 0 to 9 in the diagram here. So 0 is actually physical pin 1, but the code's managing that mapping for us. We can just use these numbers on the diagram. And so by the time we get down to 9, it's actually physical pin 12, but we don't need to worry about that. So we're saying we're going to use each of these pins, and then I'm using a constant and saying I want it to be an output. So that means I want to be able to control the voltage that goes out of that pin, and it'll either be nothing or it'll be 3.3 volts. So once we've got our list, I'm a JavaScript person, our list of these things, we can then do something with them. So I've got a while loop going on here, and all it's doing, which is what you see happen on the board below, is it's iterating through the LEDs list. It's setting the value of each pin to 0, so no volts, which is basically off. We're having a little sleep, and then we're setting it to 1, which is send 3.3 volts or turn it on. So what happens is the LED goes off, we sleep for 0.2, the LED goes on, and then we're going to do the same thing backwards and turn them off. And then we're going to sleep for half a second at the bottom. So that is how you get this effect that you can see over to my right there, where it's sort of going up the chain and back down again. So pin 0 is connected to the light that's closest to the camera, and pin 9 is connected to the red light that's furthest from the camera. And let's see if we can just hold it over here so you can sort of see that more easily. The blue is a little bit hard to see through the tape, but rest assured there is a blue one at the bottom there. So that's doing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. 10 things. So what we're going to do, or what we need to do, is take this code and we need to map it or mash it up with some code that connects to a Redis server and talks to Redis. And we've done this Redis bit on these live streams before. So I built something that showed, what was it doing? Oh, it was reading temperature and humidity and light values in a room and pushing that into a Redis stream. So we were using the Pico as the stream producer, whereas here we're using it as more sort of informational service that doesn't take part in the actual streaming of the data, but displays some information about the state of the stream. So it's like a metadata display thing. And what we did before was we used a Redis client for MicroPython called Pico Redis, and I chose, because it's a single file, to just paste that file into the project when we did it before. So what I've done here is, and again I'll put this in the chat, so Raspberry Pi Pico W MicroPython Redis boilerplate. That's quite a lot of words. There we go. So let's see how that, yeah, that is quite a lot of words. But what we've got here is a repo that you could use if you want to do basically anything with Redis as a start point. So let's just quickly look at what is going on with that. And what is going on with that is we have this Pico Redis.py. That's a client that came from, let me just find that. It comes from, here we go. So there's a GitHub user, Spotlight Kid. I've actually reached out to them before to say, hello, I'm using this on stream. So if you get to see this, please do contact me. We'd love to see if we could help you with this client, or just have a chat about how it's going. But basically, they provided this client. It works on the basis of it doesn't know very much about what comes back from Redis, so you have to parse out the responses, but it allows us to send arbitrary Redis commands, which is exactly what we want. If you're interested in how it works, I've got IoT streams again in my playlist back on the YouTube channel. So if you go down to YouTube, find my playlist, I did some live streams where we built a Bloom filter, which is another sort of data structure, and we looked at the Redis, what's called REST wire protocol for that, and we replicated that. But basically what this is doing is this is taking functions that we call in MicroPython and parameters that we provide and turning them into REST strings for sending across the wire to Redis, and then it's sort of regurgitating the response from Redis. So it's a very basic Redis client, works great in these environments because this is very, very low memory, low processing power. So that's what we've got. So back to this here, that's what that file is. What this file here is a boilerplate that you can take and use for any sort of Redis work that you want to do on these Pi Pico Ws. And you do need the W because you need Wi-Fi, so you need to be able to connect to the network to get to Redis. We're not going to run a Redis server on a Raspberry Pi Pico W. That's not going to happen. There's no operating system and it just isn't capable of it. But we can run it as a connected network device that acts as a client, and that's exactly what we want. So what I'm doing here is the Pico is a microprocessor, not a sort of single board computer. So there is no operating system. Essentially, we have to program everything we want to do in Python. So normally we'd rely on, say we were using like a regular Raspberry Pi with a Debian-based operating system. We would have that as part of boot up, use some configuration to connect to an available Wi-Fi network. And then we can just assume when we get to an interactive shell or our service runs as part of boot up, that it can depend on that network connection being there and just do things on the network. That's not the case on a microcontroller. We have to manage that ourselves and we have to establish it. So I'm importing the network package here, and we're basically just using some boilerplate code that says we want to connect to a WLAN, a Wi-Fi network, and we want to connect using an SSID and a password, and I've just put those in a file called secrets.py so that you don't have to commit them to GitHub and you don't have to share them on a live stream, so that you all can't come round to where I am and connect to my Wi-Fi network. So we're going to keep those secret, but basically those are like my Wi-Fi SSID and whatever password you use to connect to it. And then what we're going to do is we're going to have to establish a connection to that network and maintain it. So I'm saying here, hang around until the Wi-Fi is connected and we've got a status of at least 0, which is like a non-error status. And while we don't have those things, we're just going to basically sleep for a bit and try again and just wait and see if the hardware's managed to connect to the Wi-Fi. So it's kind of a polling approach rather than event-based, hey, I'll register a callback and you tell me when there's a connection. But once we get to this line here, we can be pretty sure that we've got a connection and we can move forwards. So the way that the Pico Redis client works is it's pretty similar to other Redis clients. You just create an instance of it and you pass in some parameters. So again, in my secrets file, I've got a Redis host, so where Redis lives, and I've got a Redis port. And in this case, if we also specify a password in the secrets, we are going to use the Redis auth command to connect to that. If you were doing something more complicated, like you've got a Redis access control list user, so you've got an actual username and a password, which is great practice because you can then limit that to just the commands that you want to have that user run. So, we could limit this little device to only being able to run xinfo or something if we wanted to. Then you could also put a username in here and pass that in. And you just have to modify the code a little bit. maybe I should do that to make this a more useful boilerplate for everybody to move forwards with if you want to do MicroPython Redis. And you'd certainly need that if you were connecting to our Redis cloud service, because that always requires the password. You might as well send the username, and then you can start using access controls as they were intended, rather than having like one super user that can do everything. So once we get to here, we can assume we're authenticated to Redis and we can just do things. So now I go into a while true loop. You'll notice that all the scripts for the Pi Pico do that. Again, this is because there's no operating system, right? So we don't do something and then finish, because once we've finished, there's nothing to fall back to. It's just going to fall back to a Python REPL, and we're probably not connected to the device when that happens. So we need to write code that is basically going to run forever. And respond to events or do something on a timer. So this is doing something on a timer. We're saying while true, so just forever. We are going to call the Redis ping command. So like a lot of other Redis clients, if you're familiar with Redis Pi for regular Python or Node Redis for Node.js, for example, Redis command corresponds to a function call pretty much. We are going to call r.ping. We're going to ping the Redis server, and then we're going to print whatever comes back, which should be the string pong. And then we are going to sleep for a couple of seconds and do it all again. So this start point here is going to allow us to connect to Redis and do something. So we kind of need that, and we also need this. So once we're connected to Redis, we need to go get the xinfo stuff and do something with the LEDs. So I am going to switch to VS Code here a moment. And let's just come out of this project. And let's go start with a lot of terminals going on here. And what do we want? What did I call it? Redis Streams lag. As you can imagine, a lot of my repos begin with the word Redis, so Redis isn't a great autocomplete for me. So here we've got that project checked out. Let's do a code on that. Quickly pull it off screen in case we bring up the secrets file. And nope, we haven't brought up the secrets file. So that's good. So what we're going to do here is slightly skip ahead a bit in the interest of time. And I've taken that boilerplate code and slightly adapted it to the Redis command that I want to run. So let's look at this. So over here, we've got sort of what we had before. We're establishing that network connection. Nothing's changed there. We're establishing that. We're connecting to Redis. If we had a password, we're going to auth with the password. None of that's changed. And then in the boilerplate, we were running r.ping. So that was fine. And now we're running r.xinfo, which is the Redis xinfo command. It takes some parameters. So we're passing those in. So we're saying, what do we want info on? We want it on groups, the consumer group. And what do we want to know about? We want to know about a specific stream key. And this key here is not the key that we are working with in our example. So we'll change that to be jobs. And we'll change our consumer group name to be, we called it staff. So we're going to ask it about the jobs staff situation. And we should now have a network connection and so on. So then we're going to get a response back, and let's look at that response. And then you can see how I sort of got ahead of time and decided to parse out some things from that response. So we're going to get something out of that response. We're going to do some maths on it, and then we're going to determine how many of those LEDs we want to turn on. We haven't got any code for dealing with the LEDs yet. That can come later. And then we're going to sleep for a couple of seconds, and then we're going to ask Redis the same question again. So how do we now take this code and replace what's running on the Pi here? So we've got that LED sort of testbed code on there. We don't want that anymore. We want to talk to Redis. So what we're going to do is, from VS Code here, there's a really good extension called Pico W Go. And I don't know if you can see down the bottom here, I have connected to the Pico W that's running at the minute. It's got a USB cable that's going into my Mac. And you'll see it's connected to it as a USB modem. And if I hopefully Control-C this, then what happens now is you'll notice that the LED code stopped running. So nothing's happening over there anymore because we've basically broken out of that. And I've got a REPL in here. So I can just type Python. So I can do like 2 + 4, get 6 back. I can do print hello. Yeah, I've basically got a Python REPL. The cool thing is I can also mess around with the pins and stuff from this REPL, and we'll look at that. But what I need to do now is move this code here onto the machine. And this thing doesn't as such have a file system. It's like a serial connection. But this extension is really handy. So it's got a thing where we can move the entire project to the Pi Pico. And I'm just going to delete everything off the Pi Pico to start with. So hopefully that's good. Again, this isn't an operating system, right? So we can't do like ls. But what we can do is something like import os and then os.list/. There's nothing in it, so we wipe that device clean. So think of like Python as kind of the operating system here, if you want. If you are old enough like me to have had one of those computers in the 80s where you turn them on and it just boots to like a basic prompt and you do everything in basic language. It's a bit like that, but with Python. So there is no ls or cd, but we've got Python functions that allow us to see what's on the device. So what I'm going to do now is, fingers crossed, we're going to upload the project to the device. There it goes. It's resetting the board. It's now connecting to the Wi-Fi. So this is the print output. And hey, there we go. So it's talking to Redis, and you'll see it's basically calling that xinfo command every couple of seconds as we asked it to. And what I'm going to do is stop it so it doesn't keep printing this out. I'm going to look at what we got back. So first off, we connected to Redis. That all worked nicely. And then we ran, let's see, xinfo groups, and then jobs was our stream key. And we got this list of lists back. So if you're used to working with a sort of more fully featured Redis client, like say a Redis Pi or Node Redis, you would have expected this to have been parsed out into like a dict in Python. So it's a bit more of a structure or a nested object in JavaScript. And that's not happening in this client because it's kind of about efficiency and running in a low memory environment. So this is the raw response that's coming back from Redis. So you're going to see a lot of lists of lists. And if we look at that there versus this here, which is the actual CLI response from Redis. So this one here is basically the first group of responses. So if we have more than one consumer group, there will be a 2 down here. And then items 1 through 12 here are sort of nested in that first response. So they relate to this first consumer group called staff. And then a second consumer group would have a repeat of that. And what you see is that translates into what we get back in MicroPython here. So I've got a list and there's one entry in my list, and that's all of the information for the first consumer group, which is the only consumer group in our case. And then inside there, it's name of property, value of property, name of property, value of property, and so on. And also note the B in front of these. So that means that these are just being returned as bytes in Python. And if we want to use like string comparisons or things on them, we're going to have to decode that. So again, the client could have decoded all of this for us, and that would be a nice convenience. But when you're running in an environment with very limited resources and very limited memory, it's probably best to just defer that decision to the application developer and just convert the fields you need when you need them, because then you're doing the minimum amount of work. It might be a nice enhancement to this client to have a flag where you could say, I want you to decode it for this particular request or for all requests, which is what you see in Redis Pi. There's like a decode responses or something flag that tells it whether it should decode them all or not. This doesn't have that, which is absolutely fine. It might just be a nice thing to do a pull request for one day. So what I'm dealing with is I've got this back, and then I can basically say group info. So we're going to loop over each group info, and we're going to look for the onth element. So 0 is the field name, and then this is the value. This is going to be the name of the consumer group. So that's the one we want. I'm going to decode it to a UTF-8 string, and I'm going to say, is it the name of the consumer group that we're looking for? So if we have multiple consumer groups, this LED thing that we're building is the staff display only. So we only care about staff. What I can't do, that again might be a nice enhancement to xinfo, is what if I could do like xinfo groups, jobs, staff, and it would only bring back that staff group if it existed, or say a null response if it didn't. That might also be nice, because again, in this sort of low memory, low processing power environment, if there's a lot of consumer groups, I'm bringing them all back to then get rid of some of them. So I might actually, in that situation, consider writing something that lives on a server and like not have the Pico talk to Redis, but have it talk to the thing on the server, and then the thing on the server throws away most of the Redis response and just sends back what the Pico wants. But yeah, decisions. There's multiple ways of doing these. This is the way that we're going with, because this is a Redis stream and we want to show connecting to Redis on the Pi Pico. So I'm basically then saying, if that value is the name of my consumer group, then the current lag is the index 11 thing in there. So it's like down here, look, we have this name lag, and then we have the value 6. And then I can print that out. And what you see there is 6. And what I want to do really is, I've got 10 LEDs. So I want to use one LED to represent a lag of 2 jobs. So every 2, like, if we've got 1 or 2 lag, we'll put 1 LED on. If we've got 3 or 4, we'll put 2 on. And we also need to top out at 10, because we can't show more than 10. So what I've got for the minute in our sort of revised boilerplate is, this is Python 3 for integer division. So I've got, how many LEDs do I want to show? Well, whatever the current lag value is, integer divided by 2, and then we're just printing that out for the minute. So we would show 3 LEDs in this case. So we're then going to have to add some more code to deal with the LEDs, right? So we've got that. What we need to do is probably add some like uppercase on there. So if led to show is greater than 10, let's show becomes 10. So basically, if we get more than 10, we haven't got more LEDs than that. So there's no point trying to show more than that. We'll just be on that, showing that everything up to the red level. So there's, we don't want to overflow our LED array and so on. And we can get rid of this to do, because we kind of did that. So that's okay. So we've got this code that is talking to Redis and establishing our network connection. And then over here, we had this code that handles the LEDs. So this was my test code that just dealt with the LEDs. So we can sort of see how this works. This is probably a good example of, let's use the REPL and let's look at the Pi underneath. And I kind of wish I have more options here to set the layout, but the Pi underneath we'll focus on at the minute. So right now, if we look at the Pi underneath, nothing is happening there in camera 2. So all the LEDs are off. And what we can do here in the interactive REPL is let's do import machine. And then we can start to, that's Discord. We'll look at Discord later. Getting ahead of ourselves. We can start to remember where we put the code. There we go. So let's do from machine import pin so we can like this code exactly. And then we want to do, let's pick one of the LEDs. So let's say pin 4 equals pin position 4, and we're using them as outputs. Then if we do pin 4 dot value 1, that should turn it on. So there we go. And if you take a look down there, so we now have the 5th one from the top because it's 0 index is turned on. And if I hold this here with one hand and change that to be value 0, what you can expect is goes off. So in electrical terms, what we've done is we've sent 3.3 volts to that pin, and that's kind of how it works. So this is why I was saying I really like MicroPython for the Pico, is you don't have to go through this whole loop necessarily of write like a script out, download it to the device, try and figure out what's going on with a bunch of print statements. You can just sort of noodle away on stuff in here in the REPL, and just see what works, and then go and paste it back up into your code up here. So that said, we can do some pasting now. So we're going to need this. So let's put that there so it's somewhat alphabetically ordered. We're going to need our array of LEDs because we've got all of them. And let's make that a little bit nicer. And what we're going to do is let's steal this and get to a good known start point. So if we like Control C the code while some of these LEDs are turned on, there's no like interrupt handler that's going to say, oh, hang on, he wants to quit. So like there's no try catch finally type thing going on here. We could add it, but we just haven't. So we're going to assume nothing about the state of the LEDs. So let's put this in here and a little comment here. But until we've got some data from Redis, when we first start, we'll just turn all the LEDs off. We don't need them. And then what we want to do is when we have got something to show, so we've got this number here, what we then want to do is show however many LEDs. So how do we do that? What we want to do is do some sort of slicing operation. So if again, this is where the terminal's good down here. If I had something like LEDs equals, let's just use numbers for example, a list of 10 numbers, I can do some sort of slice in Python. So I can do LEDs like that, and that gives us, it stops at position 5, so it gives us the first 5. So that's probably what we want. The smaller number being sort of good, because if we've got a backlog of 1 or 2, that'll be the blue and the green LEDs, and then the red one was like position 9. If we wanted to do it the other way around, I think we could do something like that. Yep. And that gives us the other half of the list. But we kind of want this. So we want to show that many LEDs. So we should be able to create a list of that and then like loop over it. So something a bit like for LED in LEDs. Which one did I say I wanted? Colon, and then the something like that. What we don't want to do is do LED.value, turn it on. And so what that's going to do, hopefully, is turn on all the LEDs up to the backlog. But the backlog might have changed since last time. So if it gets higher, that's going to be okay, because we'll just like overwrite the ones that are turned on with turned on again and so on. And if it gets lower, that won't work, because if it used to be 5 and now it's 3, then the 2 extra ones are still going to be turned on. So we do need this sort of logic as well to say, and turn the rest of them off. So let's do something like for LED and LEDs. There's probably other ways you can do this in Python, but this is how I'm going to attempt to do it. Let's show to the end, LED.value 0. And then down the bottom here, we've got our sleep. So there's a chance that this might actually work. We can see about that. But what we're going to need to do to get that to work is we've uploaded the project to the Pico. So we've got all those files on there already. So see all these files that make part of this project. We need to just replace main.py. So I'll show you again. I said earlier there's no operating system. So we can do os.list brackets slash. You'll see now we actually have some files that we copied down there. The extension put them on there for us. A couple of things. So this is kind of, again, like our operating system. It's like our equivalent of an ls command. And how does it know what to run? Well, the MicroPython runtime expects a file called main.py. It's going to run that, and it's going to do whatever's in that. So that's kind of, with building a machine that essentially when you turn it on, it like runs main.py, and main.py needs to do everything that it needs to do or pull things in from other files. So what I need to do now is do, I think we can just do upload project, and it'll, yeah, it knows which ones have changed since last time. So it uploaded main.py, it's reset the board, and then let's see, this is either going to work or it's going to go horribly wrong, isn't it? So we've got LEDs to show 3. Ooh, look down there, we've got 3. So there's a blue one and 2 greens. So what we need to do now is, our Pico is merrily away looking at the lag. So let's create a bit more lag with our producer, and let's watch what happens down there on the Raspberry Pi. So 4 now. So there you go. We're still in like green territory. The backlog's not horrific. But we've now got, like, a way of visualizing this that people can just glance at. So sort of glanceable metrics. And obviously in a cloud situation, we might manage the resources. And what we need to do is start thinking about running some consumers. So we might want to run some consumers and automate that. But this is a simple example where we're pretending the consumers are real people. So look, we're starting to get into orange zone now. Let's start a consumer up, and they will start to process the backlog. So let's say, hey, Simon, get out of the break room, go do some work. And let's see if Simon getting out of break work and doing some work starts to affect our backlog. So we were at 6, and we are not quite catching up yet, but we'll get there hopefully. I could also be kind to myself and stop the producer, couldn't I? Or I could add another consumer. So we could bring we don't want that one. Let's bring Josephine off the bench. And hey, there we go. We've started to make a little dent on the backlog here. So we're down to 5 and now 4. And you can see that my LEDs are going down 3. And then hopefully we'll eventually get to 0 and everything's calm and we can all basically go have a coffee break or something. So keep going. One day we'll clear all of these jobs. There we go. So we're now caught up. So we do need about this number of people to keep the lag at 0. So we're providing good service response. So probably not a good time for a coffee now. But if we'd got, say, 3 or 4 staff members on and we hit this point, we might want to stand a couple of them down and then be like, hey, when you see the lights in the coffee room start to climb up the stack of lights here, then think about coming back and reporting for work. So yeah, that was I don't know, an overly complicated way of showing an integer value that you get back from a Redis client, but that's partly what this this series is about. And hey, look, you can see the Wi-Fi details there. So if you want to connect to my Wi-Fi, feel free. The good thing is we didn't share any Redis secrets, but that's okay. So if you want to play around with this, then you are going to need a Pi Pico, or you could have some other board that's got Wi-Fi and runs MicroPython. There's a few of them out there, especially as with the Pi Pico, the hardware is also a sort of open source design too. So more and more companies are taking Raspberry Pi's chip and they are doing stuff with it. So you could go get yourself one and get yourself a set of the lights. The lights I showed on last week's stream, they were, I think I've got a picture that I can share somewhere, a big picture of what the lights look like. Let's see if I've got that in my notes. Yeah, I do. So let's grab that. Here we go. So this is an overly complicated diagram of the lights, but basically there's 2 pins on the bottom of them. This one has slightly different color arrangement to mine. Doesn't really matter. One side is going to be all of the positives and the other side is going to be all of the grounds, and they only work one way round. So you can find that out by looking underneath or just try it out. It'll be fine. And then you'll need the resistors and you will need the breadboard and obviously the Pico W. So I'll put a shopping list for that in the description for this video. And yeah, I think that's about it for what we had today. So if you are interested in these sorts of things, then come join us on the Redis Discord. So we have a Discord community here. We celebrated a bit of a milestone this week. We now have over 9,000 members in the Discord. So thanks to everybody for being a part of that. And you'll see there's an IoT channel in here whereby I'm sharing the things that I'm doing. If you've got IoT projects, come and chat with us. We would love to hear from you. Also, if you've got, IoT or any projects, go have a look in the self-promotion channel or post stuff there. Someone built this like interactive anagram word game thing. So that's a good fun use of Redis. A few of us on the team have been playing that this week and been chatting with the developer about that. So yeah, that's kind of fun. Then what am I interested in doing for future live streams? I've got a few bits of hardware on the shelf that we can start to play around with. I've got a bit of an interest in this, which is Kaluma. It's a runtime for the Pi Pico that allows you to write JavaScript. So instead of writing MicroPython, if you're more familiar with Node, you could write basically this same thing that we've just done, you could write in Node. And we might look at doing probably something different, so we're not repeating ourselves in this with Node. And we'll look at how to get the Node environment on one of these devices or how to get this JavaScript environment. It's not Node, it's its own environment. How to get that onto one of these devices. If you're curious about how that works with MicroPython, we did that in a very early stream in the Things on Thursday series, we showed how to take a Pico W like this that is fresh out of the bag. It doesn't come with MicroPython environment on it. It assumes you're going to write C code, and how to drag and drop the MicroPython environment on it, reboot into MicroPython, and then have this REPL environment and this interactive experience that we've shown today. Yeah, I think that's kind of all I've got. So as ever, let's just do a quick, we would love for you to take a university course. They're all free and you can learn some stuff about Redis. So especially if you've maybe seen Redis as cache and you want to know what else it can do loads of other things. Particularly relevant to the IoT community would be this Redis Streams course. So we look at using that stream data structure. That is, we've used it as a buffer here. You could use it as an append-only log. These courses are free. They're mostly video and textual based. There's source code and a free instance of Redis provided for you to use and play around with them. And they have an exam or homework component. That's all multiple choice questions. It's all open book. You can take as long as you want over it. We want you to be successful. And if you score like 65% or higher on the exam and the homework, we'll issue you with a certificate, and you can add that as a credential on LinkedIn that says, you know, we Redis say that you know some things about, in this case, Redis Streams. So there are now 10 of these courses because this week we sent our .NET coding course live. So you can learn how to write code for .NET. And that is brought to you by Steve, our field engineer for .NET. And again, if you want help with that, the best place to go is back there to Discord, because as we say often, there's a Discord channel for that. So if you're on a .NET course or the Streams course or any of our courses, you can chat with your fellow students and people from the company and, you know, maintainers of the product inside the Discord, and we'll hopefully help you with any questions you have. So I think that's going to be it for today. So again, sorry about the late start today. We it's that time of the year where we do some planning here at the company, and I was involved in that for a little while. That's going to be the rest of my day, but I will update the description for this video. So if you find us on YouTube later, then what I'll have put in there will be the GitHub URLs of the source code that we're using. I will also commit the sort of general start point boilerplate. So if you want to do Pico Redis on a Pi Pico W, then I'll get you a start point that you can just basically run any Redis command in a loop and go from there. And I'll also commit the specific code that we used for working with the little device over here. So yeah, thanks very much for coming and hanging out with us today. I'll be back next Thursday. We have other folks streaming in the week. So I believe Justin and Savannah at the minute. So watch out for those on mostly, I think it's Justin Mondays, Savannah Tuesdays most weeks. All right, thanks everybody. Bye.